We're alive. So we're not doing A through D, but what we will do is we will look at the bottom two questions. All right? Which one do you want to do first? You want to do 2 or do you want to do 1? 2? 2 looks like it might be easier. I mean, that makes... Take a look at 2. What does 2 say? 2 says f of x is this function. And then it says f prime of 2 is equal to, and that's what we have to do. We just have to find f prime of 2. Okay, cool. Let's do that. Well, to find f prime of 2, what do we have to find? We have to find the derivative. So let's find f prime. F prime of x is going to be 8x to the negative 3 plus 1/2 x minus 0. Don't be surprised if I ask you that multiple times, because there will be people that will tell me it's like 1 or something silly like that. I don't want that to happen. Now here's what I do not want to see on your paper. This is the next thing I do not want to see. So looking at this, that was the exponent times the coefficient. And then we reduce the exponent by 1. Exponent times the coefficient. Reduce that exponent by 1. Constant goes to 0 when we take the derivative. So we solve this. This is not what I want to see. This is terrible. This is the worst thing you could ever do. This is like a giant slap in my face. What the heck did I do wrong here? Some of you will probably not see it. You think you know it?
Well, you didn't put the exponent number on the divided.
Okay. So I did not change the exponent to a negative. Is that mathematically wrong not doing that? There is actually a legitimate mathematically wrong thing I did. The what? Okay. Yeah. No, that's not it. There's something that's terribly wrong here. Brackets? Nope. Beautiful. Nicely done, Trin. Okay, what Trin said. I did not write the f prime of 2. I simply took the, and I said f prime of x equals this, and I told you that this is equal to that. Which is not right, because this is not f prime of, this is not f prime of x, this is f prime of 2. This is called a linkage error. And I know that it seems like that is the most minute and annoyingly small mistake that you could make, but it's something they're going to hold you to. I need to write the f prime of 2 as this right here is what's called a linkage error. This is my linkage error. F prime of x is not equal to f prime of 2. Those are not the same statements. So to be able to plug in the 2, I need to sub in negative 8 over, I am going to put this over 2 cubed plus 1. And 2 cubed is what? So negative 8 over 8 is negative 1. And negative 1 plus 1 is 0. Pretty good? That wasn't bad. Okay. So other than the weird linkage error, there was nothing that was strange to that problem, right? Very straightforward. Find f prime, sub in a 2 for the x once you've found f prime of x. Move on. What about number 1?
The instantaneous rate of change.
What is the instantaneous rate of change of f at x equals 3? What the heck are we talking about? Instantaneous rate of change of f at x equals 3. It is a rate of change at a specific point. Because it's a specific point, we're talking about what type of a line? Tangent line. We're talking about a rate of change, which means it is slope. We are talking about the slope of a tangent line. Another phrase for a slope of a tangent line? derivative. So now what the question is saying is that what is the derivative of f at x equals 3? What do I have to do? Find the derivative. F prime of x is 3x squared minus 12x plus 8 minus plus 0 because there's nothing there. Do you have to put the plus 0? Yes. Certainly. Absolutely. No. There's no need to put a plus 0. No, don't do that. Do I put equals and start subbing in 3's for the x's? Certainly not. We do not want linkage errors. Do not make me have to become Miss Bruce at Pasadena High School and literally make a stamp that says linkage error. She doesn't even write it on her papers anymore. When people have linkage errors, she just has a stamp, and she just stamp. Yeah, I know, that's pretty awesome, not going to lie. She has like 3 stamps that she keeps putting on people's papers. I really need to just make stamps. 3 times 3 squared minus 12 times 3 plus 8. That's 27 plus 8 is 35, but if we subtract 36 from that, we should get negative 1. Well, okay, to be fair, I also just did that problem like 30 minutes ago. So, of course, I can come up with the numbers quickly. That's right, I already saw the answer. What's the difference between 1 and 2? Like, what is the procedural difference to both of those problems? Nothing. There was literally nothing different in either of those pieces of work. I found the derivative, I subbed in an x value, and I got an answer. Same exact steps. Different words. You ready for this? About a 90% success rate nationally. 30% success rate nationally. Well, what does that tell you? It tells you that people go through these questions and they get caught up in a lot of the words. I am going to do my best to keep alternating between instantaneous rate of change, slope of a tangent line, derivative. I'm going to try to come up with as many ways to say the same exact thing as I can in class so that you are used to me constantly varying the vocabulary to internalize that. With that said, clearly as a math teacher, how do I like to write stuff? I don't like to write it as sentences. I like to write it nice and fast. So keep me, if I'm writing questions and they all start looking the exact same, I'm not doing you justice. All right? And I need to make sure that I'm asking you those types of things over and over and over again. Pretty good? Yes. All right. Then let's move on. Basic derivatives, day 2. Question 1. Determine the point or points, could be multiple, at which the given function has a horizontal tangent line. You have enough information to actually solve this problem. Problem is you've got to be able to figure out what on earth do I mean when I say, what'd you say, Andy? 0 slope? Why do you say that? Jerk. You're supposed to take a longer period of time for me to come up with, let people struggle, not just come up with an answer immediately. God, you're screwing up my... No, Andy is 100% correct. Horizontal tangent line, okay? Horizontal tangent line. You hear horizontal line, you think slope is 0. So this says slope of the tan line equals 0. Or, what's another way of saying slope of a tangent line? Derivative. F prime of x has to equal 0. Well, to find out when f prime of x equals 0, I should probably find f prime of x. What do we got? Now, linkage error or not? No. Yes linkage error or no linkage error? No. No linkage error? Why? Because I am telling you I want to figure out when does this equals 0. So this is perfectly acceptable. It's when I start substituting the x that we run into a problem. So I want to set f prime of x equal to 3x squared minus 12, which is 0. We need to solve for that, so what do? Okay, so we can add the 12, get what? 3x squared equals 12. X squared equals 4. Is that where you were heading? Okay, then what's x? Plus or minus 2. What do you think the most common wrong answer here is? Okay, so here's the thing. Here's what I want to point out. What you did here is there anything mathematically incorrect about what we just did on the board? No. Now, remember, my goal is to try to make sure that I set you up in a position. So I am going to take on the role of teacher doing weird things. I am going to choose on problems like this to typically take it and start factoring the heck out of it. Because if I write it out as a factored form, what am I not going to make the mistake of? Plus minus. Because I can see when x is at x plus 2, my x has to equal negative 2. When I got x minus 2, x has to be positive 2. So it's just realize there's nothing wrong between either of these methods. This will still give me this, won't it? All of this will all work out. It'll all wind up fitting. But I want to be very careful that I put the right answer in. Now, am I finished? Why not? Man, all right. What the heck am I teaching you all for? No kidding, man. You guys are killing all my fun. You know, I usually ask these questions hoping that, there's a little bit of like a, People are like, no, you're answering. Come on. So f of 2 is what? 2 cubed minus 12 times 2. And we got negative 2 cubed minus 12 times negative 2. That's what? 8 minus 24? Negative 16. And this is negative 8 plus 24. Hopefully that actually makes relatively decent sense because we know that a cubic can actually look like that. So on the negative side of it, we would get a maximum, a relative maximum, and on the other side of it, we would get, on the positive side, we would get a relative minimum. So does that seem to fit our bill? We're good to go. Couldn't tell if Andy was looking at that concerned. I think you were just looking at it, staring it down, making it feel intimidated by you. All right. Oh, dang it. Come back. There we go. Now I have room. Second question. Determine the points at which the function given has a horizontal tangent line. F of x equals x plus 2 sine of x from 0 is less than or equal to x less than 2 pi. Yes, totally. Horizontal tangent line, what's that tell you? By the way, that's going to be something we're going to solve a lot of. Like, Andy's going to go crazy solving for 0 type a lot of. You're going to get so used to setting things equal to 0, you're going to miss problems because you're just going to magically make them equal 0. Huh? You wish problems didn't have letters. Oh, what's wrong? You not like that with the sign? We could skip it. I like my classes. Other classes I've had before that are like, yeah, let's skip it. Let's totally skip it. Of course, and you can agree with this, Armando. I guess we could skip all the signs and all the logs and all the exponents and stuff. And by the time we're done, we'd have what, like 6 questions on the test that we could do. It's true. You'd be left with about 6. So f prime of x equals 0. So let's find it. F prime of x. Nina's back there like, no, I want to know how to do the problem. F prime of x is what? 1 plus 2 cosine x. And we're going to set that equal to? That's cool. That's cool. All right, we have to do some algebra. I don't want algebra. Cosine of x is -1/2. Okay, those of you who have learned the unit circle by degrees, you take the degrees and leave the radians in your head. Take the degrees, ball them up, set them on the table, and when you go to leave, you can throw them away. We're not going to ever use a degree in this classroom. So what? 2 pi-thirds? That's one of them. So, cosine of x, 1/2. So I know it has to be a pi-thirds, right? So, negative, I want it on the left side of the y-axis. So I need to have something slightly larger than pi-halves, which will be 2 pi-thirds. Where's the other one? So where would 5 pi-thirds put us? 5 pi-thirds is a little bit larger than 3 pi-halves, which would put us over here. So we want 4 pi-thirds. What I typically have done with the unit circle, and yes, you need to have those memorized. Just go ahead and do it now. Correct? Yeah. Yeah, just... Yes, yes we do. You keep lying to yourself, Kevon.
Imagine like someone writing down their formula chart, like just putting it on during the test.
Just writing it. All right, are you done?
No.
Oh snap! This is getting to be annoying. We got to find the f of 2 pi-thirds and the f of 4 pi-thirds. By the way, I'm curious. Why on earth did they put this here? Why did they put this 0 is less than or equal to x is less than 2 pi? Why do I have to mention the domain? Why can't I just leave it open? Yeah, because remember, 1 plus 2 cosine of x equals 0, that could happen an infinite number of times. So we got to make sure that we set a domain so that we say, okay, here's the stop, here's the finish, and we're good. All right, f of 2 pi-thirds, so that's 2 pi-thirds plus 2 times the sine of 2 pi-thirds. Now, y'all ready for this? Pretend that this is a free response question real quick. I can literally write parenthesis 2 pi-thirds, comma, 2 pi-thirds plus 2 sine of 2 pi-thirds, and I would be done.
No.
Remember, I told you didn't have to simplify. That goes into trig as well. So if I wanted to, I could write 2 pi-thirds, parenthesis, 2 pi-thirds, plus 2 sine of 2 pi-thirds. Now I could say that that's my answer. And that's correct. On the free response. Of course, if this were a multiple choice, they wouldn't do that. And I mean. So let's simplify it down to multiple choice. What's the sine of 2 pi-thirds? That's cosine. Cosine of 2 pi-thirds is -1/2. What is the sine of 2 pi-thirds? Square root of 3 over 2. Square root of 3 over 2 times the square times 2 is? There's one of my points. 2 pi-thirds, comma, 2 pi-thirds plus the square root of 3. Got one more to find. 2 pi-thirds plus 2 sine 4 pi-thirds. What's the sine of 4 pi-thirds? Beautiful. Whoops, I put 2 pi-thirds. That should be 4. Please don't copy from what you wrote above. So that's going to be a negative root 3 over 2, so that's going to be minus square root of 3. So that's my first point. My second point. If you're curious, could an answer that gross beyond the non-calculator portion of the test? The answer is, heck yeah. Pretty good?
Yeah.
Not too bad.
I have to review my unit circle.
Yes. might be, just to give you a heads up, now that we're getting into this trig stuff, don't be surprised if I start giving you little pop quizzes just on sine of this, cosine of this, tangent of this, secant of this, cotangent of this. I'm going to keep popping you with those. Yes, sir. Fantastic. Okay. Andy had a brilliantly amazing question. It was, when I went through the problem, I had f prime. I solved for this. He was good with getting the 2 pi thirds plus 4 pi thirds. The question was, why did I put the 2 pi thirds and the 4 pi thirds back into my original f of x? Why didn't I plug them into f prime of x? F prime of x finds a slope. Remember, f prime of x is technically the slope of a tangent line. And this question wanted to know points. To get a point, what do I need? I need an x and a y value. F prime gives me slope. What would f give me? F gives me the y value that goes with it, right? So that's where the difference comes in. If I'm looking for a point, I want a position on my graph. So a position on my graph is going to be obtained by taking f of that number. That's a really good question because that's going to be useful in this problem. By the way, if I ever qualify your question as a really good question, it's not that whole, don't you really hate it when someone asks you a question and they say, ooh, that's a good question. You're thinking, yeah, of course it is. No, it's because the question that you asked was really something I skipped over that needs to be said. Well played. Or something that I assumed people caught. Clearly someone didn't catch it, so I need to go back and double check it. So thank you. Find k so that the function f of x equals x squared plus kx will be tangent to the line y is equal to 2x minus 9. Oh my goodness. Holy smokes. What do you think, Nina? Nina's already thinking. She's like, excuse me? Oh, well, you're excused. Find k so that the function f of x equals x squared plus kx will be tangent to the line y is equal to 2x minus 9. Holy moly. Where do you think we go? Okay, hold on, because I got a bunch of people who are coming up with some ideas, so I want to make sure that I'm just kind of catching around. So, what did you say, Andy? So make f of x its derivative. Is that what you said? So what would that be? So you said take the derivative of f of x, which would be 2x plus k. And you wanted to do what with that? What do you think? He wants to take the derivative of this, and he wants to make it equal to the derivative of this. He wants to take the derivative of f of x, f prime of x equals 2x plus k. He wants to set that equal to the derivative of y. So the derivative of y would be dy dx, and that would equal what? What do you think? Is that legal? Why? Derivatives, and we want to find if they're tangent. If this is true, then the derivative of the tangent line should equal the line that it's tangent to, right? It's the slope. We want to compare a slope to a slope. Brilliant. You were. Now that's really good. A typical mistake that happens here is students want to take the derivative of this and set that equal to just 2x minus 9. Why would that be a mistake? I'm comparing a slope to a point, which we can't do. Beautiful, brilliant. Yes, yes, woo, I like this. This is making me happy. So So I can take my derivatives. F prime is equal to, of x is 2x plus k, dy dx is equal to 2, and I can set those equal to each other. I can take 2x, actually let me rewrite that just real quick. I want to take f prime of x and set that equal to dy dx. So I'm going to set 2x plus k equal to 2. So they have to have the same exact slope because the derivative of the tangent line should be equal to the line that the derivative of the actual tangent line I'm looking at itself. By the way, did I really even have to take the dy dx here? No, because it's just a slope, which, oh look, the calculus works on linear functions too. All right, got a slight issue. How many variables do I have? How many equations do I have? I have one equation, because I really only created, because I'm looking at a relationship between these two functions. I have one relationship between those two functions, but I have two variables I need to solve for. Dang it. That's right. I'll tell you what I'll do is I'm just going to give you the easiest problems in the world on everything. We're just going to do the easy notes. We'll do the easy homeworks. We'll do the easy tests. And then when you get to the AP test, you can all take it and look like morons. It's true. I even recorded that, and that's okay. I have no intention of making you all look like fools in May. See? Your present is going to be that you're going to get a 5 on the calculus test. All right, so we're stuck right here right now. We need to be able to come up with another relationship between these functions to be able to deal with this.
Well, you have to do f of x equals y as well.
Why would that work?
Because like since they're both going to be tangent to each other, it will be technically the same like the derivatives.
So you're saying the derivatives have to be the same because they'll have the same slope. So if I set the f of x equal to the y, now what I'm telling them they're going to have not the same line.
Same line, like the parallel?
No, not parallel.
Or the same point?
Same point. So this is saying that at a specific point on those lines, at some x, they'll have the same exact slope. This particular slope of this line will be equal to the slope of the tangent line of this function. The other thing that I need to account for is I need to check their points. If these are tangent, they should share how many points? 1. So I need to set f of x equal to y, or x squared plus kx equal to 2x minus 9. With that, I have now created two relationships between these equations. I have two variables I need to solve for. I can now solve this problem. How do you want to do it? Substitution. Well, what am I going to substitute? Okay, we'll solve for k. So k is what? 2x, or sorry, 2 minus 2x. Right? Which means over here, what can I do? I can substitute that in. So this is going to get really gross really fast. Plus 2 minus 2x times x equals 2x minus 9. Oh my god, that's a lot of x's. Let's try to make some of them disappear. If I distribute this, I get 2x and I get negative 2x squared. So x squared minus 2x squared is negative x squared. And then this is going to be plus 2x is equal to 2x minus 9. Ooh, I like that. 2x and the 2x will, they'll subtract out from each other. So now I just got, really, x squared is equal to 9. I went ahead and factored out the negative already. If you want to put the negative in, you can. But they're going to cancel each other out, so I'm not going to put them there. Which means x has to be. Are you done? Yeah, that's where that square root thing comes in. Yes, sir. Yes. So what I did here is I set this function equal to this function. Because remember, for a line to be tangent with each other, I said this will be tangent to this line, right? So if they're tangent, what does that mean? That means they share exactly one point. And if they're tangent, the derivatives need to be equal to each other. All right? So in the points section, I found out where the shared common point would be. In the derivative section, I figured out where they would have a common slope. Now what's interesting is that there's not just one answer to this. There's actually going to be two, because now what I need to do, now I need to go back and solve for k. You're going to learn some new notation here. K when x is equal to 3. A vertical line is technically a mathematical symbol for is evaluated at. So this is k evaluated when x is equal to 3. Or 2 minus 2 times 3, which is 2 minus 6, which is negative 4. I could also write k evaluated when x is negative 3, which is 2 minus 2 times negative 3, which is 8. Which means that when we've got the equation x squared plus 8x and x squared minus 4x, both of those will have a line that is tangent to this. That's weird. I would have to actually graph those to see that. That's not something that I see in my head. All right? So for those of you freaking out thinking that you have to be able to just notice that, I don't notice that. If you do notice that, then you're awesome and amazing. How we doing? We breathing? Cool. We'll deal with that when we get there. Can't have that shirt. That was the first survivors. A sexy shirt.
But I can imagine like evaluated to.
All right. What I would like you to do is I would like you to do the middle problem here. We are going to do that top problem. I just do not have the time to do that problem the way I would like to do it, and that is okay. Also, heads up, we do have a test this upcoming Friday. The purpose of this test is not necessarily to be a grade on you. This is not going to be a, oh my God, if I fail this test, I failed the class. I will guarantee you that's not the case. Okay, hopefully that brings everybody down. It'll be put in probably as just a homework grade because we've only had a whole whopping 3 weeks, and we'll never make a single test will determine whether you pass or fail. Never. All right? So, now 2 tests, that's a different story. But the point of this test is to see where you are at and help me to evaluate, A, what assistance you need. For my BC students, it will also help me identify, do you need to take your class and slow it down so that you can have more time to wrestle with the problems. Remember, AB is not a dumb math class. AB just means that you do have more time over it. It's less problems. It's still a whole bunch of math. Now I know that if you signed up for BC, you're in this class because you wanted to be in this class anyways, right? Yeah. I screwed up my schedule. Now they can't fix it. I'm stuck. All right. So you need to be able to answer this. You do have a homework assignment. However, it is the questions are 1 through 5. I only want you to do questions 1 through 4 on the assignment. Okay? Yes. Because I'm sure you all would argue that you really want to do that 5th problem, right? Yes, ma'am. Yep.
So you find a derivative of a derivative.
Yeah, and we can find like the derivative of the derivative of the derivative.
That's unnecessary.
That's unnecessary. It's all necessary.
Oh.
All right.